this is Mr. Humbard here. For this video, I'm going to be going over the Chapter 7 Momentum, 7.1. So to start this, we're going to go into slideshow, and this is Chapter 7. Just never fixed that. Alright, so momentum, it's going to cut me off a little there, is the amount of mass moving at some velocity, p equals mv. This can also be written as m times the definition for velocity, which is displacement in some time frame. And it has the units of kilograms times meters over second squared. Meters over second, sorry. Kilograms times meters over second. Here we have a quick problem, 1400 kilograms times meters over second, because mass times velocity is momentum. So we just multiply them together. I should get 17,500 kilogram meters over second. Okay. Momentum depends on velocity because of that equation. P equals mv equals m delta x over delta t. So the change in direction indicates a change in momentum as delta p is some initial velocity minus some final velocity. And the momentum that was in this section and in general is going to be in one dimension. It's also a vector because displacement's a vector, velocity is a vector, so momentum is a vector. Okay. So the change momentum, this is where we usually can factor out the m because we're not dealing with rockets that change mass. If we have change in momentum, we will have the same mass usually. And we have another one, the momentum total, which is going to be momentum added up. These can be separate masses because we can add them up. But for this one, you just add them all up. So there's a couple different ones, the change and the momentum total. You might also see this is as many momentums as you want, as this weird Greek letter. This is a sigma. Means sum. Alright. So we have this 0.5 kilogram beanbag dropped from the table. We'll assume v initial equals 0. And as this velocity 4 meters per second, v final equals 4. And we want the change in momentum. So for this, just 0.5 times delta v, or m times delta v, equals delta p. It's my formula from before. Alright, my number is 0.5 times final is 4 minus an initial is 0. And we'll say the magnitude here and the reason for that is I don't want to have to worry about which direction is up and which direction is down. We'll say down is positive, or just use the magnitude of this. Just want to know the value instead of having to worry about negative or positive here. So just 4 times 0.5, or 4 over 2, which is 2 kilograms meters over seconds. Right. For this one, same thing. Find magnitude. 0.5 kilogram ball dropped on the table. This time around, I'm going to say This is the initial, this is going to be the final. So 0.5 kilograms. Change momentum going down initially is at hitting down in the floor. We'll say negatives downward because we can't. Positive is upward. Down in the floor, so negative for initial minus final, positive for going up. And negative is positive, plus 4, 0.5. These are both meters over second. So this is going to be 8 divided by 2, or 4 kilograms meters over seconds. Okay. So last example, because we talked about total already. We have this city park, and for this, I'm going to say the ducks will be swimming in the positive direction. It doesn't tell us which one should be positive or negative, but since we have the magnitude here, it's not going to end up mattering. And this is total momentum. Notice we have 2 separate masses, or 3 separate. P1 plus P2 plus P3. But the ducks we can add together because there's 2 of the same. It says 2 ducks, they have the same mass and a goose. So the duck swimming at 4 kilograms. We can add this 1.1 plus 4 times 1.1. These are positive because I chose that direction to be positive. The goose is swimming in the opposite direction, so plus 7.6 negative 1.3. And if I add this together, I should get 8 times 1.1 minus 7.6 1.3. When I do that, I get negative 1.08. However, I want and that's going to be my delta P. I want the absolute value of this though, because it says find the magnitude. And that's going to be 1.08 meters over seconds times kilograms units. And I know the direction of momentum is going to be in the goose's direction because it has a bigger value as compared to this, because I got a negative number for my answer. And that's the answer to all of them. So, have a good day.